Welcome to the deep dive. Today, we're jumping straight into the AI Daily News Digest from April 26th, 2025. Lots happening, as always.
Absolutely. We've gone through it all to pull out the really interesting bits, the stuff you actually need to know about.
Yeah, cut through the noise, right? Get you those aha moments without the overwhelm.
Exactly. So let's get started.
Okay, first up, Deep Wiki. This comes from Cognition, the folks behind Devin. What's the story here?
Right, DeepWiki. So they're pitching it as a free encyclopedia for basically all public GitHub repositories.
An encyclopedia for code, like all of GitHub. That's ambitious.
It really is.
Yeah.
Think Wikipedia, but specifically for open source libraries and projects. The idea is to make understanding code easier.
Okay, how does that work in practice? Like, how do you find something?
It's actually pretty neat. You just take a normal GitHub URL, say github.com for more/ropo, and you swap out github.com for deepwiki.com. So deepwiki.com /ropo.
Simple enough. So you land on a page. What's there? Just a summary.
You get a description. Yeah, kind of like a Wikipedia entry for the library. But the really interesting part is the chatbot.
Ah, yes, the Devin connection.
Exactly. There's a Devin-powered chatbot right there on the page designed to help you figure out how to actually use the code in that repo.
Like an interactive guide for every project. That could be huge for developers, especially jumping into new code bases.
Definitely.
Yeah.
Imagine trying to contribute to a complex project.
Yeah.
This could seriously lower the barrier to entry. The digest mentioned some early tests they ran.
Oh, yeah. How did those go?
They tested it with React and Astro repositories, which is fun
Yeah.
because that's what the AI news site itself is built on.
Right.
And the feedback was apparently very encouraging. So, yeah, it seems like it has real potential.
Okay, DeepWiki. One to watch. Next up, we've got TCQ. TACQ. What is that?
So TCQ stands for Task-Aware Quantization. It's from a research paper, and it's all about model compression, making LLMs smaller.
Compression. Always a big topic. But usually you compress, you lose accuracy, right? That's the trade-off.
That's the standard problem, yes. But TACQ is making waves because it claims to get really high accuracy even when compressing models down to 2-bit precision.
2 bits. Wow, that's tiny.
Yeah.
How does it manage that without, breaking the model?
Well, the key is in the name, task-aware. It uses a specific dataset, a calibration dataset, to figure out which connections, which weights inside the model are absolutely crucial for the tasks it needs to perform.
Ah, okay. So it's selective.
Exactly. It identifies those critical weight circuits and tries really hard to preserve them while compressing the less important parts much more aggressively. Smart, huh?
Yeah, that is clever. So it knows what to keep. All right, sticking with compression, as another one mentioned, DF11.
Right, DF11. This one popped up in an online forum discussion. Stands for defloat 11. It's also about compression, but specifically for inference time.
Inference time. So when the model is actually running, doing its job, how is this different from TCQ?
It's a different technique. DF11 uses Huffman coding, like zip files, find common patterns.
Yeah.
It does something similar with model weights, combined with a blockwise approach. The goal is to take standard BF16 models and shrink them by about 30%.
Okay, 30% reduction. Significant.
Yeah, it gets the weights down to around 11 bits each, so about 70% of the original size. And the big claim here is lossless output.
Lossless, meaning the model's answers don't change at all.
That's the idea. Unlike typical quantization methods where you often sacrifice some precision, what they call lossy compression, DF11 aims to keep the output identical to the original.
That sounds ideal. Smaller model, same results. Any catch?
Well, the benchmark showed it's pretty good. For handling lots of requests at once, batch processing, its speed was comparable to the original BF16, sometimes even a tiny bit faster, and way faster than offloading to a CPU.
Okay, that's good for efficiency. What about single requests? Latency.
Ah, that's the trade-off. Single batch latency was reported as being around 40% slower than BF16.
Okay, so maybe better for some use cases than others. Throughput over single request speed.
Precisely. And it's open source, which is great. The code's on GitHub. There's a paper on R. People can dig into it.
Good. Openness helps. And they mentioned the benefit over lossy methods is determinism.
Right. Because it's lossless, you get predictable, consistent results. You don't risk those occasional weird outputs or performance drops on certain tasks that can sometimes happen with lossy compression. It maintains maximum task coverage, as they put it.
Gotcha. Were there comparisons to other similar techniques?
Yeah, they mentioned some prior work. There's something called SM7, which is apparently more for just storing models compactly. and also things like 8-bit quantization, which is used at runtime. But DF11 is trying to hit that sweet spot of significant compression without any loss, which is appealing if memory is super tight or determinism is critical.
And people are keen to see it integrated into common tools.
Definitely. The discussion mentioned wanting to see it in things like llama.cpp or VLLM to make it easier for everyone to use.
Makes sense. Okay, switching gears quite a bit now. Tessa Rust Task 217B. Sounds very specific.
Very specific indeed. It's a new 7 billion parameter language model, but trained only for the Rust programming language.
Just Rust. Interesting. Why do that?
Well, the underlying question is, can you get better performance, better coding ability by hyper-specializing a model on just one language compared to these giant models trained on everything?
Depth versus breadth, essentially.
Exactly. Maybe focusing intensely on Rust allows it to capture nuances that a broader model might miss. It came with an open dataset too.
Okay, but the digest mentions some skepticism, concerns.
Yeah, quite a bit actually. The main issue was a real lack of transparency. Very few details on how the dataset was made, how they checked its quality, or how they even evaluated the model's performance.
That's not great. If you don't know the data quality.
You can't really trust the model, right? The suspicion was that the data set was probably just synthetically generated, get a bigger model like GPT-4 to just spit out a load of Rust code.
Without proper checks and balances.
Right. No clear info on validation, unit tests within the data, nothing like that. People pointed to other projects like from Oxen.ai or Together.ai that are much more open about their data pipelines.
So transparency is key here. The community wants to see the workings.
Absolutely. It's crucial for building trust. So, interesting idea. The Rust-only model, but the execution, or at least the documentation around it, raised some red flags.
Okay, got it. Right, final topic. This one's, well, pretty fundamental. AI and consciousness.
Yeah, heading into deep territory here. Anthropic, one of the major AI labs, announced they're starting a new research program specifically looking into AI welfare.
AI welfare, what does that actually mean?
It means they're seriously starting to ask the question. As these AI models get incredibly complex and capable, could they potentially develop their own subjective experiences? Could they, become conscious in some way?
Wow, that's a big question. Are they saying it's happening now?
Not necessarily predicting it's imminent, no. It's more about starting the conversation, building a framework to think about it as AI advances. But it definitely sparked discussion online.
I bet.
Yeah, there was mention of someone claiming, like, a 15% chance models are conscious already.
Seriously, 15%.
Yeah, and that drew some pretty strong pushback. Someone else commented that it was as absurd as saying there's a 15% chance this collection of atoms my computer is on is conscious. Just highlighting how differently people view this.
It really shows the range from maybe it's possible to that's just silly.
Exactly. It's deeply philosophical. What even is consciousness? Could it emerge from silicon? But the fact that a major player like Anthropic is dedicating resources to studying AI welfare, well, it shows this isn't just science fiction anymore. It's becoming a serious consideration.
Definitely food for thought about where all this is heading. Okay, so let's quickly recap today's deep dive.
We had DeepWiki, that potential Wikipedia for code from Cognition.
Then TACQ and DF11, two different takes on making these giant LLMs smaller and more efficient, one lossy but smart, one lossless but with latency trade-offs.
Right. Then the specialized Tessa Rust model, an interesting experiment, but highlighting the absolute need for transparency in data and evaluation.
And finally, dipping our toes into the very deep waters of AI consciousness and welfare, now an active research area.
Hopefully that gives you a good snapshot of some key things happening right now, those important nuggets of info.
Absolutely. And maybe a final thought to leave you with. As we see these advances, like making powerful AI more accessible with compression, and as we even start asking these fundamental questions about AI understanding or consciousness, what comes next? What are the possibilities or maybe the ethical puzzles that we haven't even started thinking about yet?
Yeah, it feels like we're constantly uncovering new layers to this whole field. Lots to keep exploring.